Titration problem 2 is a weak base. We're told we've got ammonia, NH3, and that it has a Kb, and that means it's got to be a weak base. And we're going to be titrating it with a strong acid. HNO3, nitric acid, is a strong acid. So, just like the previous ones, we need to know where we are on the pH, or on the titration curve, keeping in mind that because this is a weak base titrated with a strong acid, our curve is going to look like this instead, but we still have the same criteria. Originally, we're going to use the Kb expression. From that until we hit the equivalence point, we're going to use the HH equation because we're creating a buffer as we titrate it. At the equivalence point, we're going to have to focus on the Hb ion. The conjugate acid is the only thing in the water that's going to make a difference, and after that we are just diluting. So A is asking for the original pH of this solution. So to do that, all I have to know is the concentration of the base and its Kb. Keeping in mind, this is what's happening inside the solution. The ammonia is reacting with water to make its conjugate acid, NH4 plus, ammonium, plus OH minus. So that's why it's a basic solution. It's creating an increase in OH minus. So, my expression, Kb equals the concentration of the ammonium times the concentration of the hydroxide, all divided by the concentration of the ammonia, NH3. I have a number for Kb. I have a number for the concentration of ammonia already. I need to find numbers up here. These two must be the same number, because originally when I drop ammonia in water, for every one of these, I can make one of those. So these are both the same. So this should look familiar by now. We are going to have x squared over 0.500, and that's going to equal Kb, 2.4 times 10 to the minus 5. So x is going to equal the square root of Kb, 2.4 times 10 to the minus 5, times the concentration of the weak base, 0.500. So x happens to be, in this case, 3.46 times 10 to the minus 3 molar. That is the concentration of the hydroxide and the concentration of the ammonium. But it's the concentration of the hydroxide that we can use to find the pH. Not directly, but indirectly. pOH equals the negative log of the concentration of OH minus, which means pOH equals the negative log of 3.46 times 10 to the minus 3. pOH equals 2.460. I have 3 after the decimal because I have 3 in my measurement when I started. So pH equals 14 minus pOH, which equals 14 minus 2.460. So pH equals 11.540. Again, 3 after the decimal here because I had 3 significant digits up there.